Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 5 to the power of n minus 4 to the power of n is equal to 3 to the power of n, and we will solve this problem for the values of n. And the very first thing we are going to do is, here first I can divide both sides by 4 to the power of n. So by dividing both sides by 4 to the power of n, you will get 5 to the power of n over 4 to the power of n minus 4 to the power of n over 4 to the power of n is equals to 3 to the power of n over 3 to the power of n. And now you see that these two terms are gone, and now we can apply here the nice exponential law here. You know that if we have a to the power of m over b to the power of m, so it is equals to a over b to the whole power m. So now this expression be the 4 to the power of n, because I can divide both sides by 4 to the power of n, so that we will get, or we can apply this exponential law in the first expression, and you will get the output in the form of 5 over 4 to the power of n minus 1 is equals to, now we can again apply this exponential law in the right hand side as well, and you get 3 over 4 to the power of n. After that we can focus on both of the sides, and here you see that this 5 is greater than 4. We can write 5 is greater than 4. If this 5 is greater than 4, it means that 5 over 4 is greater than 1, and if 5 over 4 is greater than 1, then 5 over 4 to the power of n is also greater than 1. So we can say that this function is increasing function, and here you see that when an increasing function is lesser by 1, then it remains the increasing function. So it means that if you can this function increasing, then 5 over 4 to the power of n minus 1 is also increasing function. And now we can focus on the right hand side, and you see that we have 3 over 4 to the power of n, and here you see that 3 is less than 4 and 3 over 4 is less than 1. If 3 over 4 is less than 1, this means that 3 over 4 to the power of n is also less than 1, and if it is less than 1, then we can say that the right hand side is decreasing function. And now we make the relation of increasing function and decreasing function. So you know that the graph of decreasing functions look like in this form, and the graph of increasing functions is look like in this form. And you see that this is increasing function and this is the decreasing function. So if increasing and decreasing function are intersect only one point, this point, so this all visual or graphical representation of this question will tells us that this question has only one solution, because if you can see the question statement, we cannot say that this question has how many solutions. So that I can explain it by in this way, and first I can check this question has how many solutions? So increasing and decreasing function intersect at a single point, so it means that this question has only one solution, and this point be the only solution of the given question statement. So now our claim is to find that point, so that in order to find this point we can just check by inspection the given question statement. So our question statement is 5 to the power of n minus 4 to the power of n is equals to 3 to the power of n. And now I can check it by inspection the values of n. So first I can check at n is equal to 0. After that I can check at n is equals to 1, and after that I can check at n is equals to 2. So first I can check n is equal to 0. So when you can put n is equal to 0 in this question statement, you will get 5 to the power of 0 minus 4 to the power of 0 is equals to 3 to the power of 0. And here you see that 5 to the power of 0 is equals to 1 minus 4 to the power of 0 is equals to 1 is equals to 3 to the power of 0 is equals to 1. And here you have 0 is equals to 1. And we can conclude that 0 is not equal to 1. So it is not possible. So that we will reject this case. And now we can check at n is equals to 1. So when you can put n is equals to 1 here, you get 5 to the power of 1 minus 4 to the power of 1 is equals to 3 to the power of 1. And 5 minus 4 is equals to 1 is equals to 3. And again, here you see that 1 is not equals to 3. So we again say that it is not possible. So if it is not possible, we will reject this case again. And now we can check n is equals to 2, and when you can put here n is equals to 2, then you get 5 squared minus 4 squared is equals to 3 squared. So 5 squared is 25 minus 4 squared is 16 is equals to 9, and 25 minus 16 is equals to 9 is equals to 9. So this shows that n is equals to 2 satisfies the given question statement, this statement. So we can say that this question has only a solution, which is n is equals to 2. So we can say that n is equals to 2 be the only solution of this question, and this point in which increasing and decreasing functions are intersect, and this point is be the n is equals to 2. So and finally we conclude that n is equals to 2 be the final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.